Dear friends, in today's class, we'll be understanding the concept of design thinking with the help of an example. That example is development of tree. In design thinking, once we have a problem, then the problem can be solved by number of methods. In divergent phase, we'll be getting as many solutions as possible. Once we get more solutions, then we have to go for the convergent phase. In that phase, we will be selecting the best optimum among the solutions which are available. So this is the whole concept of design thinking. So in today's class, we will be understanding the concept of design thinking by taking a problem which is development of tree. So here I have models were made by different methods. Here we will be listing four methods. One is by finding the true length of all the edges. So if you have a tray like this, then we will be finding the true length of this edge, this edge, this edge as well as this edge. So I will be finding the true length of all the edges. Then I can get the development. The second method is by finding the true shape of the slant plane. If we have one slant plane, I will be finding the true shape of the slant plane. Third method, by considering the tray as a frustum of a square pyramid. So what I do is, I will keep upside down. So it will be a square pyramid. It is a frustum of a square pyramid. So once I consider this as a frustum of a square pyramid, I can find the development. The last method is by making all the slant faces to lie on the ground, each face intact with one edge of the bottom square. So we will be seeing all the four methods one by one, and we will be selecting the best method in the convergent phase. So this is the first method, which is drawing the development by finding the true length of all edges. So we will be drawing the top view of the square pyramid, and this is the front view of the square pyramid. So I will be having one slant face A, B, C, D. Let us find out the true length of all the slant edges. So AB is in true length, CD is also in true length. What I do is, I will be finding the true length of the slant edge BC, as well as I will find the true length of the diagonal BD. So if we want to find out the true length of the slant edge, I will make this slant edge parallel to VP. So this is what I am doing here. I have this edge BC. I am making it parallel to VP. So I am getting the side as BC1. So I will be taking C1 to the front view. From C dash, I will be drawing a horizontal line. I will be getting intersecting point C1 dash. B dash C1 dash is the true length of the slant edge. Likewise, I will be finding the true length of the diagonal also BD. So what I do is, again I make the diagonal BD to be parallel with VP. So I will be getting BD1. So from D1 you draw a vertical line, and from D dash you draw a horizontal line. The intersecting point will be D1 dash. B dash D1 dash is the true length of the diagonal BD. So with this, I am now having true length of all the edges. So how to construct the development is, I will be drawing the line AB, which is having a length of 40 mm. Then I know the true length of the slant edge B dash C1 dash. That distance as radius, B as center, I will be drawing an arc. Then I know the true length of the diagonal BD. which is also equal to the true length of AC. So from A as center, the true length of the diagonal BD as radius, I will be drawing an arc. The intersecting point will be C. Likewise, I can locate the point D also. With A as center, slant edge B dash C1 dash as radius, I can draw an arc. Then the body diagonal BD as a true length of the the diagonal B dash D1 dash. With B as center, I will be drawing an arc. The intersecting point will be D. So ABCD will be the true shape of the one slant face. Once you get the true length of one slant face, then we can copy and paste, we'll be getting other three faces also. At the bottom, I can draw the square, which is the bottom of the tray. So this is one method we are understanding from the basic concept. Development is nothing but getting the true length of all the edges. So I have the true length of AB, I have the true length of AC, and I am having true length of BD. So this is one method. In fact, this method will take more time. The second method is drawing the development by finding the true shape of the slant plane. So here we have the top view, we have the front view. The slant plane is PQRS. The front view, the slant plane is seen as a line P dash, Q dash, R dash, S dash. So when it is seen as a line, then if I look in the perpendicular direction of this line, I will be getting the true shape of the plane. So this method is very simple. So what I do is, to this line, I am considering auxiliary plane x1, y1. I am getting the projectors through Q dash as well as P dash. Then to locate the points from xy, I find the distance of r. So from here, I fix the distance of r. Then to locate the point Q, I am finding the vertical height of this point Q from xy line. That distance, I keep it from here. I will be getting the point Q. Likewise, to locate the point S, I will take this distance from xy line, vertical distance of S. In the projector through S dash, I will be finding the distance. I will be keeping the point S. Likewise, to get the point P, I will be taking the vertical distance of P from xy line. I measure this distance. I keep the same distance from here. I will be getting the point P. So I will be getting PQRS, which is one slant plane. I can do copy and paste as I did in the previous problem, and I will be getting the development of the complete tray. So this method appears to be simple. It consumes less amount of time. The third method, what we'll be seeing is drawing the development by considering the tray as a frustum of a square pyramid. So if you see a tray like this, I can keep it upside down. Thereby, it becomes a square pyramid which is cut by a horizontal plane. So we can call this as a frustum of a square pyramid. So that is what I have done here. This is my top view and this is my front view of the tray. I extended this so that this is a square pyramid, vertex O dash. Now my job is to find out the true length of the slant edge O dash A dash, as well as the true length of the slant edge O dash B dash. So what I do is, I know the top view OA. Again, I make it parallel to VP. I am getting A1. So from A1 you draw a vertical line. To cut this XY line, I will be getting A1 dash. Likewise, OB, make it parallel to VP. I am getting B1. From B1 you drop a vertical. From B dash you draw a horizontal line. The intersecting point will be B1 dash. Thereby, O dash A1 dash is the true length of the slant edge OA. O dash B1 dash is the true length of the slant edge OB. So to draw the development, what I do is I am drawing a arc. This arc I am drawing with OA center, O dash A1 dash as radius. I am drawing an arc. This is the outer arc. Then the same center I am drawing the inner arc. The radius of the inner arc is O dash B1 dash. With O dash B1 dash as radius, this O as center, I am drawing the inner arc. Then I can take any point in the outer arc. Let us call the point as A. I will be cutting the outer arc with the radius of 70 mm. I will be getting the point here. Another arc with the same radius of 70 mm. I will be getting the point here. Likewise, I will be getting the 4 slant faces. Then the radial line OA, all other radial lines will be cutting the inner arc. So join those inner arc points. So likewise you join this point, join this point, join these points, join this point, and you will be getting the slant main edges here. So if we join all this, I will be getting 4 slant faces. I can also draw a bottom square. So this way I can get the development of the tray. So this is the third method. The last method of solving the development of tray is by making all the slant faces lie on the ground, each face intact with one edge of the bottom square. So what I mean is, I am having a tray. I open out all the slant edges, slant faces to lie on the ground, and each slant face will be intact with the one edge of the square. So this is how I will be getting the development, and we will be seeing how to solve this problem, how to get the answer. So what I do is, I am drawing the top view, I am having the front view. So my slant face is EFGH. What I do is, I will be getting the true length of only one slant edge, that is EF. So I will make EF parallel to BP. I am getting EF1. From F1 I am drawing a vertical line. From F dash I am drawing a horizontal line. The intersecting point will be F1 dash. Join this E dash F1 dash, which will be true length of the slant edge. So I am getting the true length of only one slant edge. Then to draw the development, what I do is, I take this bottom square as it is. I am drawing the bottom square. Then what I do is, so for this line, I am finding the center. So from this center point, I am drawing a vertical line at a distance of 35 mm from this point. Again I am drawing another vertical line at a distance of 35 mm from this point. Thereby, the distance between these two vertical lines will be 70 mm. Then what I do is, I have taken the true length E dash F1 dash, that is radius H as center. I am cutting the vertical line at the top here as well as at the bottom here. Likewise, with the true length of the slant edge, E dash F1 dash as radius, E as center, I am cutting the vertical line here as less here. Now if you join, I will be getting one slant face, I will be getting the second slant face. Then I am having this vertical line for a length of 40 mm. I have the center point of this vertical line. From this point, you draw another line at a distance of 35 mm, a horizontal line. Again, from this point, you draw another horizontal line at the bottom at a distance of 35 mm. So the distance between these two horizontal lines will be 70 mm. Likewise, with H as center, with the true length E dash F1 dash as radius, I am cutting the horizontal line here as well as here. With the same radius, I am cutting the horizontal line here as well as here. So I will be getting the third slant face, I will be getting the fourth slant face. So this is the development what you are seeing here, and the first three methods will be giving the same answer, which will be like this. So problem can be solved by four methods. Problem 1 to 3, though we use different methods, will be having the same kind of development, whereas the fourth method will be giving the development like this. Now we will be seeing the method which is best one for the industry. As far as industry is concerned, they want to reduce the cost. So they have to solve the problem with less amount of time, less amount of material also. So if you go through this method 4, what is the cutting length involved? So if you find out the length of cutting here, in the fourth method, if you take this is the length of cutting. So this length, let us take approximately as 30 mm, and here by this method you can find out the length as 70, 1, 2, 3, 4. So 70 into 4, that is 280. Then I have this slant edges true length, let us take approximately which is 30 mm, 1, 2, 3, 4, 5, 6, 7, 8. So it will be 30 into 8, that is 240. So this method gives cutting length as 520 mm. Now let us go through the previous method and let us see the method here. 1, 2, 3 will be giving the same kind of development. So here the slant length here is 30. Again here the slant length is 30. So we have 2 into 30, that will be 60 mm. Then we have 170, 70, 70, 70. So we have 4 into 70, that will be 280. Then we have this 40 mm, 1, 2, 3, 4, 5, 6. So 6 into 40 mm, that will be 240 mm. So the total length of cutting here is 580. So the solutions given by method 1 to 3, the cutting length is more. That means we will be wasting more amount of material. Whereas the last method, the cutting length is only 520. So there is a reduction of 60 mm, which is the cutting length reduced by fourth method. Moreover, if you go to the sheet metal industry, so this consumes less amount of material, less amount of cutting. So thereby the industries prefer the method which is cost effective. So thereby we can conclude by conversion that this is the best method of solving the development of tray. Though we have other methods also, so we have to choose the best method by convergent phase, and for this we can choose the fourth method as the best method to solve the problem. So thank you very much. Thank you.